Hi everybody, thanks for tuning in to another math video here. In this one, we're going to look at how you're going to be using the inverse trig functions. All right, the inverse trig functions, well, one of them is already kind of familiar to you. You've already seen the inverse tangent a few times. Hopefully you saw that other video that we did. It's been a while since we did this, but hopefully you remember something about that. I'll show you an example real quick. But the other two trig or inverse trig functions are inverse sine and inverse cosine. They all have that little -1 there. So you've got inverse tangent, inverse sine, and inverse cosine. That's just kind of what we call them. And as you recall, for inverse tangent, an inverse trig function in general is used to find an angle measure for a right triangle. All right. Actually, when you do a lot more math later on, get more higher math using trigonometry, you'll use the inverse trig functions to find other things also. But right now, we're just going to find angles in a right triangle just to get the practice down. All right, so here's a right triangle. When you look at angle theta right there, just thinking about opposite, adjacent, and hypotenuse, those three sides of the right triangle, you see that 5 is opposite the angle and 18 is adjacent. So opposite and adjacent means you're going to be using tangent. So the tangent of theta is 5/18. All right. So to find the measure of angle theta, I mean, right now we know the tangent of theta, but we don't know the angle, the measure of the angle. So we'll use the inverse tangent of 5/18. And you just put that into your calculator, and it's pretty easy right there. Just make sure your calculator is set up for degrees, and you know how to do this little procedure on your calculator, and you'll have no trouble getting through these problems with the right answer. You put that in there, and your calculator says that the inverse tangent of 5/18 is 15.52, which means then angle theta is 15.52 degrees. And that's all there is to it. So let's do a couple more using sine and cosine, all right? Because it works the exact same way for sine and cosine. Once you have the basic trig equation figured out and written down, all you're going to use is the inverse trig function for that same fraction. Here's what I mean. So let's see, we've got a right triangle there, triangle ABC. You got one side labeled 4, one side labeled 12, and let's see, the first thing we want to do is to find the measure of angle B. All right, well, when you look at angle B and those labeled sides right there, the side opposite angle B is 4, and the hypotenuse of the right triangle is 12. So if you think for a second, I know this is early, you just started using sine and cosine, but which of the three trig ratios, sine, cosine, tangent, uses opposite and hypotenuse? All right, so hopefully you're remembering the SOHCAHTOA little memory trick, and you realize that sine of angle B is 4/12. So that's the first challenge in doing this, and it may be the hardest part about this whole process there, is making sure that you remember which trig function is appropriate for the angle that you're trying to find. So the sine of B is 4/12. That means you can say the inverse sine of 4/12 equals B. And that's, you notice that we're just switching places there, and that's how you do it. You put that into your calculator, and you get inverse sine of 4/12 is 19.47, which means the angle B is 19.47 degrees. Okay, so all the work happens in making sure that you have the right equation, and then the calculator takes over, and it's pretty easy from there. So to find the measure of angle A then, the other angle in that right triangle, let's say we look at that now, and for angle A, that 4 is the adjacent side. So we've got the adjacent side and the hypotenuse, and that means we're going to use cosine. So the cosine of angle A is 4/12. Notice it's the same fraction, 4/12. But for angle B, that 4/12 represents the sine of angle B. And for angle A, 4/12 is the cosine of angle A. All right? But it's the same thing, really. You're just going to put, inverse cosine of 4/12 into your calculator, and you figure out pretty quickly that the measure of angle A is 70.53 degrees. Now, one thing to note about this is that in any right triangle, the two acute angles, like angle A and angle B, are always going to add up to 90 degrees. So we could have taken angle B and just subtracted it from 90 degrees, and that would have also given us the measure of angle A. So once you find one angle, the other angle, there's a couple of different ways you can find it, okay? All right, let's do a couple other ones here, and I'm going to let you guys kind of take a look at these two problems. And I'm going to ask you to pause the video here a little bit, and work these out for yourself. So just find the missing angles there for those two right triangles. Find angle A and angle B in the one on the left, and find angle M and angle P in the one on the right. And I'm just going to ask you to pause the video now and work those out. All right? All right. See you in a second. Okay, so hopefully you did that. You worked those out, and for angle A, you're going to use the inverse sine of 19.5 over 25. That's the opposite over hypotenuse for angle A. And let's say we use this alternate method here to find angle B. I'm just going to take 90 degrees minus angle A, whatever I get. All right? So when I use my calculator there, I'm going to get 51.26 degrees for the measure of angle A. And if I subtract that number from 90, 90 minus 51.26 is 38.74 degrees for angle B. All right, so let's take a look at the other triangle then. Angle M, you would use the inverse cosine function since we've got the adjacent and the hypotenuse for angle M. Okay, make sure you see that. Cosine is adjacent over hypotenuse. So you would use the inverse cosine for angle M, and to find measure of angle P, we could use the same fraction there, 12 over 16, but in this case, for angle P, that 12 is the opposite side, so you would use sine, opposite over hypotenuse. All right, so that's just taken care of by your calculator, and you should get these two angle measures for angle M and angle P. And that's how you do it. It's a pretty quick thing. I hope this was enough of an example to get you going there. Make sure to ask a question or leave me a comment in the forum here where you find this video. And then we can discuss any questions or problems that you're having doing this. All right, be well, everybody. I'll see you in the Zoom.